Basically, I really caution you against spending the time to build these awnings unless you really need a strong awning. This is a 9-foot aluminum awning that I got free on Craigslist. I don't know how old it is, but it's obviously quite old. It has so many layers of paint on it that it doesn't have the thermal conductivity that aluminum has. Or, yeah, at least as far as my hand touching it is concerned. I discovered it doesn't even sound like aluminum anymore. It's got so many layers of paint. But it's been around for a long time. This thing is made out of flimsy aluminum, and it's kind of surprising that it's as stiff as it is. I mean, when it was on the ground, this thing was wobbling all over the place. But it feels fucking rigid, at least in the back and forth direction. Kind of amazing. It doesn't have any cross bracing underneath here, and I haven't really bothered to think about it a whole lot, so I still don't understand how it gets its rigidity, but it has probably a lot to do with the flange up there being screwed in multiple spots. You can see that it's riveted in a single place, here and here, to the two support members. There's an aluminum bar here, and there's just a piece of channel, presumably 0.045 hardened aluminum, right up here. And you can see it's got a single rivet, not a blind rivet that would have a hole in it, a single rivet in the middle. And that allows the aluminum to expand and contract and flex slightly where it bends right there. So it's a good design, actually, as far as thermal expansion is concerned. And the top lips on these things are designed such that the whole thing can flex. The lip is independent, and it holds this assembly in it, and everything can move around. It's real nice. We don't have that that luxury with hand tools to make it quite so good there. Although we can do quite a lot. Look at how flimsy this is. I mean, it feels like it weighs nothing. It is so flimsy. And yet, it's lasted so long. That is kind of amazing. You gotta be an engineer to make stuff like this work out, or just have some experience. Please take note that there's a single pivot point connecting this structural member to this structural member. This is the factory built one. They're both very flimsy. This structural member is rather close to the end here. And see, it doesn't even sound like aluminum, it just has so much paint on it. This stuff, the shape here helps resist forces that direction. So you could have, if you're using 0.025 or 0.020, whatever material this is, you could have some structural rigidity and distance below the supporting member that resists the force of this parachute, having the wind push it that direction. So this is the continuous top flange that holds the awning on, the professionally built awning. And it might be difficult to see with this terrible camera, but it flexes along the way in the heat. There's definitely some waviness going on. But that flexible flange allows for expansion and contraction of the flange, and then this whole assembly beneath it can expand and contract within that gripping mechanism. With vinyl siding, you have a fastener hole that's oblong, and your fastener goes through here, and initially you fasten it in the center if you're at the average temperature of the year, and you fasten it pretty loosely, and as the whole thing expands and contracts, it can travel along this fastener, and your fastener doesn't have a whole lot of force against it, but it just slides against here year round, year out. And so that's one method you could use of attaching your awning. If you're going to use that method, the flange here, the material that this oval is going to be cut into, has got to be pretty strong. If you're not going to go shopping around or searching around for alternate sources of structural beams and sheet metal, then discountsteel.com and ebay.com, then your prices will be as follows if you're using this mock standing seam roofing method. For structural supports for a 5-foot awning, you're looking at $108 plus $92. That's $200 when you could be paying $175 online from generalawnings.com. For a 10-foot awning, you're looking pretty good. You're looking at about half price, depending on which of their awnings you choose. For a 20-foot, you're definitely looking at half price. You're going to want to factor in your 5 hours per 5 feet of construction if you're novice. And if you're not a novice, you could probably get it down to 2.5. This is assuming you want to choose the 1/8 inch wall square tubes of 1.5 inch and 1 3/4 inch widths, and then 0.032 inch aluminum. This does not include your fastener cost. Let me apologize. I don't have a microphone. I'm speaking into my headphones that are plugged into my microphone jack. Secondly, this is my first time building an awning, and usually I wouldn't make a video unless I didn't find anything on there. And the only reason I'm making a video is trying to reduce the social burden. It's probably going to be a much better deal for you to go online and buy an aluminum awning. Yes, I am following a written script, and I have to have it on screen so I can read it. But you can also kind of check out awnings in the background, I guess, while I'm reading this. And it's not all script, that's for sure. I have a lot of footage. It's just that my communication is terrible. So I have to write this shit down and read it. Anyway, industry standard thickness of sheet metal is 0.020 inches or 0.025 inches aluminum sheet metal. And it usually has something like 0.040, 0.045 inch thickness hardened aluminum for the structural members. They can get away with using those because they have engineers and they have R&D budgets, and they just try to make something that'll satisfy certain physical conditions, and they can test their designs and all that stuff. But we just need to build it once and make sure it's working good, so we're going to use heavier materials. They also tend to use some of the more rigid sheet metal that they can work with, and that keeps the sheet metal stronger. And I don't know what alloys they use. I think it's like 5005 is a popular one now, for at least for roofing. Don't really know about awnings. So for shorter awnings, it's generally just as cheap to buy a new one than to build one. Awnings longer than 10 feet, partially due to the costs of shipping, tend to cost about half as much than they do to buy. However, metal supply houses do often carry aluminum square tube, and they'll have their own pricing, and I don't know what kind of pricing they got. So I only know what I've seen online, so you might find some cheaper deals there. And then the thing about shorter awnings, though, is that the supports don't need to be quite so strong in order to resist the forces of the wind and snow. So you can probably get away with using things like aluminum beams scrapped from mirrored closet doors or big sliding glass windows. Port's awning design has proven to be adequate. It's pretty sturdy. Could be sturdier. It's not too bad here. But it's kind of tough to fit those things together to form the frame that you need to. But if you got some nice thick sheet metal, like some 0.063 inch aluminum that you can get off eBay, and you can shape connections out of that, and you'll see that I've built an entire framing unit out of pure sheet metal. As an example, so you can just like use some of those ideas you might get from there to figure out what you could do for your special little project. If you don't have any sheet metal tools, then expect to pay at least $350 for tools. And I'll go into more detail about tools later. Slatted awnings aren't as strong, and I've never actually seen like a snow load rating for one of them, so I don't really know if they can handle snow, typically. But they often have numerous cross members, maybe once every 2 to 4 feet, that hold the slats into position. And I have an idea of how you might be able to build one. I've never tried. They don't resist wind-driven rain quite so well, so it won't protect your windowsills from moisture damage as much as a solid one. Okay, here's an example of an idea of what to do for slats. Here is your angled beam that's angling away from the house. Let's pretend the wall is there. Now I'm just going to place this in a way you can see it. So I guess you're looking at the side of it and the wall's right here. This is obviously too thin to support your weight, but you'd rivet it against the beam here and here and here. And you hear this? That's pretty freaking rigid. And that's the same sheet metal as this and other flimsier sounding stuff, but it's just the bends that are put in it that make it strong. And you just like maybe rivet it twice here or something, and you know, have your other support farther down, and this would travel over to there, and then you'd have a slat beam. You'd place slats every so often. So that's my slat idea. If you want to learn about corrosion, you can go to corrosiondoctors.com. But if you want to just take my word for it, if you're going to expose your aluminum to sea breezes where there's a bunch of salt in the air, then you're going to have issues if you don't paint the aluminum surfaces and protect them from the salts coming into contact with the aluminum. The only metal that you want to be in contact with your aluminum that isn't aluminum is 300 series stainless steel. There's different kinds of stainless steel. The 300 series, it won't respond to magnets, and it tends to be pretty soft. It's non-hardenable. Holy shit. And most of the self-tapping stainless screws you're going to come across are 410 stainless, and you don't want to use those. Those will rust, and they will react with your aluminum, and your aluminum will disappear. It's not as bad as if you're using zinc-coated fasteners or galvanized or galvalume fasteners, which are total shit. Don't use those. Just say no to shitty fasteners, unless you want your aluminum awning to disappear over the years. But I don't want to be talking to a person like that. You should just sign off my video right now and get the fuck out of here. Aluminum has a high coefficient of thermal expansion. It's about the same as vinyl siding. Generally, over the year, you can expect a temperature difference of about 100 degrees Fahrenheit. And for aluminum, this translates into about 0.1 inches of expansion and contraction over the year for every 7 feet. Now, if you don't paint your aluminum white, or have it bare and shiny, then it's probably going to get even hotter in the sun, and it's going to expand and contract even more. And if your aluminum is really rigid, and all that expansion is being transferred to the fasteners instead of to bending the sheet aluminum to deform slightly and perform what's called oil canning. If you don't have flexibility between your fasteners and the expanding sheet metal, then it's going to put force on the fasteners. Unless your fasteners are loose and the holes that the fasteners are going through are large and allow for the material to expand and contract a certain amount. That can totally be done. It's readily easily done with roofing stainless screws that have cupped washers around them. Just don't fasten it too tight. They can expand and contract a bit. So the more rigid that your assembly is, and the longer it is, the more likely you're going to have either loose fasteners with oblong holes that the fasteners are going into in order to allow the unit to expand and contract, or to have a sort of clip system that holds it from underneath and then holds it from above. I can't figure out a way to clip it in just from beneath if you're using like square tube. I guess there are ways around it, but let me show you at least one idea. Let's say this is your structural member. If you had a bottom clip that goes onto the side of the house, pretend this concrete's the side of the house, and you're screwing it into the side of the house, and you screw that up ahead of time. And so this beam will be at the edge, the top edge of your custom-built aluminum awning, and you could let it sit in here. It would have to be a channel that fit it better than these two pieces. But the problem is, of course, that it would want to lift off. But it could totally slide around, you know. And you'd have just like little U sections of this clip, presumably to save the cost of materials. But you'd need clips that secured it downward as well. You'd need something that's screwed into the wall above your awning that kept the whole assembly inside this bottom clip. And it would have to be pretty tight tolerances so that you have the sturdiness. You know how when I pressed against the awning and gave it some lateral loads, it was pretty strong? Well, I think that has a lot to do with it being securely fastened at the top along that strip. But if it was really loose, I kind of doubt that it would be quite so strong. In that case, you might actually go the extra mile and have a cross brace that goes like that on either end of the awning, and that would help with strength that way. And maybe you wouldn't really need a super tight top and bottom clip configuration if you're going to do a clip-in awning at the top for expansion and contraction. You're going to have to decide on what kind of shapes you want your awnings to be, and that's totally up to you, but some things you might want to consider are the angles of the sun throughout the year in your location, and what windows you're trying to cover. A south-facing window generally doesn't require quite so much coverage to block the sun out as a west or east-facing window if you're really trying to block the sun out at all times of day. You might just check out the sun angle on your south-facing windows in your locality during the times of year which you find the temperatures to be disagreeable at, and choose to block the windows during that time of year. To get the angle of the sun, you might go to susdesign.com/sun angle. That is like sustainabledesign.com/sun angle. If you're trying to build a door awning, then do consider wind-driven rain and whether or not that wind-driven rain will be blocked by that awning. And you'll notice by the shadow that if this were a window, this awning at this time of day would not be covering that. So you'd need to either have a wider awning, so the shadow would be wider, or a deeper awning that goes farther down. The combination of those is up to you. For much of the remainder of this video, we're going to be assuming that you're going to be building a mock standing seam aluminum awning. And the reasons for this are that large pieces of anything cost a lot to ship.
So you're probably not going to want to pay those shipping charges, which can easily be $500. It doesn't matter how much the material weighs. It's just going to, if it's huge, it's going to be expensive to ship, especially over 8 feet in length. So you can go on eBay and you can pick up a 12 by 48 inch by 0.032 inch thickness for $8, plus a little bit shipping. Not too bad when you buy 8 or 10 of them. Now the profiles that you're going to be able to make at home, the easiest one being the overlap, you can look up standing seam roofing profiles in Google Images to get this image for yourself. But the profiles that you'll probably be able to make at home with a sheet metal brake are the overlap, the single lock, and a modified version of the snap-on with clip. The easiest one is the overlap. I'll let you be imaginative. Oh, you could also build the T, but that would be even more difficult. Some of these shapes, actually all of these shapes, are going to require that you use a hand seamer for anything more than 135 degrees. We got 180 degrees here. We got 180 degrees here. We got 90 degrees here, but the top cap is going to be a 180 degree slice. And then we got 280 degrees here. So you'd need to use the hand seamer for all these. And whenever you use the hand seamer, it's not going to be pretty. Just warning you. Sometimes, if your piece is small enough, you can fit a 135 degree angle back into the sheet metal brake and just clamp it down a bit. But you want to be careful that you don't clamp it down all the way and make a closed sandwich. Otherwise, you're going to have to open it back up in order to insert this underside.
Here is a super ghetto fragilistic expialidocious example of making standing seam roofing profile. This is the underleg here, and it should be shorter than your upper leg, and usually you'd actually mark things out, but I'm just gonna try some. Profile. Now that's the maximum bend I can do in here. It's only 135 degrees, but I can kind of smash it down with this. Oops, I smashed it a little too much. But since I have really short pieces, I can just jam it in there. So that's a mock standing seam roofing profile.
Now I've done an even more ghetto method because I really wasn't interested in doing the standing seam thing because it takes extra time. I have access to flat sheet metal and I can just use that. So yeah, you'll see my cheesy way to do it. One thing you don't want to do is have two pieces of aluminum flat in contact with each other where the moisture will wick into them. This picture didn't really have much to do with it. But let's just say that this is aluminum here, and this is pretty flat to the rain, and the rain's coming in here. Water's going to collect underneath this crack, and that'll cause corrosion over time as the salts build in there. So you don't want the flat parts in contact with one another. But if they're vertical and they're against each other, water's going to drain out of there pretty well. Speaking of water, these are blind rivets. Those are the kinds of rivets you'll probably be using because you can get away with having access to only one side. But let's say this is the downward angle of the awning right here. You're going to have water dripping into this hole, and it's going to go through the rivet into the structural beam beneath it. And it's also maybe going to get in between this crack, especially if you didn't clean out your rivet hole. This presents a problem, and that's because rainwater will accumulate beneath that hole. And if it's open framing beneath there, then you're fine. But if you got a closed box, you gotta make sure that there's at least some sort of airflow so that moisture doesn't collect inside the tube. It's gotta dissipate somehow. So you might drill some holes. You might already have gaps and holes. Depends on your situation. Most of you, just like me, probably have really shitty houses that were built by fucking assholes who didn't give a shit about you. And in that case, they probably used wood, otherwise known as tree corpse or termite food or dry rot food. And it becomes necessary in order to preserve the structure to use caulk between our aluminum awning and the side of our house. Otherwise, we risk moisture infiltration and penetration into the wood, which increases moisture-related damages because moisture makes the wood more edible for these things. If you type in good exterior caulk into Google, then one result, for me it was result number 3, should be sterlingpropertyservice.com. And they'll have a pretty decent article on the different types of caulks, what are their advantages and disadvantages, and you can choose what kind you want. Different caulks will have different amounts of solids in them, so there will be different qualities in between.
These are all stainless steel screws. They're all 300 series. None of them react to magnets. They have a pretty big thread. That's suitable for wood. It'll grip into wood pretty well. It won't grip into thin sheet metal very well, because if it's going into thin sheet metal, then only one of these threads is going to actually penetrate. So when there's a pulling force, it'll pull on the fastener in an asymmetrical way, and it'll be a lot easier to tear through. But for 1/8 of an inch, number 14 or 1/4 inch stainless screws like this, they'll fasten into beams like that pretty well. And this point will drill right into hardened aluminum. This has a fine thread. It's good for sheet metal kind of stuff, but it's not stainless steel. It's not 300 series stainless steel. I don't know if they make fine thread 300 series stainless steel screws. This is a stainless wood screw. It has a cone head. You want pan head, probably. But if you have the cone heads like this, you might get a stainless washer and put it down there. And then you might get some good fastening power out of that. Here's a stainless bolt. It'd be a pain in the ass to use these, but if you need to, you could drill a big hole that's smaller than the thread, jam it in real hard. You could probably get that. Here is a stainless steel rivet. The grip range, that's the thickness of material that it'll go into, is pretty limited. It can really only grip about 2 of my pieces of sheet metal. More than that, and it's got some serious trouble. So we tend to go with a longer one. These are aluminum rivets, but they have steel stems. It's easier for your tool to grip onto steel stems, but if there's any of them left inside the hole, you're in trouble. These are $10 on Amazon for this whole bin, so it might be worth it to use the steel stem ones. That's your call. Now, aluminum rivets, they come in different alloys of aluminum that are of different rigidities and different strengths. Here's a pure aluminum rivet. It's larger. It's a 3/16 inch. Notice it doesn't react to the magnet. It has a very large grip range. But at Home Depot, it's $10 for 50 of them. And that sucks. So, depending on your application and how many rivets you want to drill into, you can choose whatever kind of rivets you want to buy. These 2 rivets are not the same diameter. If I drill the correct diameter 3.1 millimeter hole that's for this rivet won't even make it in. If I drill the correct size hole for this one, and I stick this one in it, and I use the rivet gun, it won't stick in there very well. It'll be almost useless. So, You got to get the right size drill bit for your rivet. Here are two different types of riveting tools. Most people use a hand riveter. It's got various size holes into which we put our rivets. And there's a gripping mechanism in here. And you pull this 2 or 3 times, trying to keep this head stable so you don't bend the leg on the rivet. And then your rivet's done. It's a lot of work, and if you have to hold a rivet down in order to keep your pieces together while you're using this tool, damn, it's a pain in the ass. Here's a rivet gun. This one's $53 on Amazon, but I can't recommend it because after my job ended, the little rubber piston in here disintegrated in pieces. Other people have had better luck with this particular model. I don't think it's got a brand name, but just go and read the reviews.
こちらに支店を出すというので一緒に連れてきてもらったんです。
おじさんが。いやー。サイトさん。スカロン店長、おじさんってまさか。
はい。
誰がおじさんだって？違いました。お姉さんです。いい加減におれ。おれ。怖え。待てー。話してもらおうか。関係ねえだろ。それともてめえが出してくれんのか？出すのだと。なんだ？物足りないのか？お前たちのような不良の心を正すのは努力や友情ではない無償の愛だ。イヤホー！抱きしめてやるぞ！こんなチャンスがめったにないんだ！逃がさんぞ。
Look, there's a spider. For longer spans, if you're going to build your own beams, you can go with the 1.5 inch by 1.5 by 1/8 inch square tube, and then to connect those sections together, you'd have sections of 1 3/4 by 1 3/4 by 1/8, and you can just slip the 1.5 inside the 1 3/4 and put a few fasteners in it just to make sure it doesn't move around. And it'll be a super strong, ridiculously strong support beam. And it'll be relatively affordable. So for a 9-foot awning, we're looking at $160 shipped for it. Okay, I've got materials for more beams than is required for one awning here. Now, I've done a wider box beam, but it's a pain in the butt because the metal likes to flex. So in order to drill and rivet through, it helps to like progressively move across the beam if you're doing a thick beam. But yeah, that was a mistake. Even though it's rather sturdy, like it'll support my weight over some sawhorses, which is great. A tip about putting these things together is to start it with the second piece. The second piece is going to be the most difficult to insert. Is to start at an angle. And then press it down from there. And if you got a gap like this, kind of bang it on the ground. There we go. Alright, these should be pretty snug. It really helps to get those 90-degree angle bends there. Plenty strong. I feel no flex in it, and it's pretty much stronger than anything you'll find in any other awning. Although there are awnings from that are approved in Miami-Dade that are made of aluminum, and they certainly are stronger than this. I assure you, this is plenty strong for most wind conditions around the United States.
Notice there's a downlit at each edge.
All right, here it is. It's about 150 rivets. Have fun doing that by hand. There's a line of rivets underneath here. Line of rivets to there, connecting it to these beams. I did not try to do a professional job. Notice how ugly that is. But that's all right. You could easily do better if you try and you actually like measure shit. Yeah. I just wanted to get this thing over with so I could show you that it works. And it's quite sturdy, I assure you. So, you can see it does flex under a bouncing 180-pound load. Maybe, I don't know, maybe 100 pounds is being transferred there. I tried to get to the center span because it's going to be the weakest point. And, I'm pretty happy, you know. Now, if your goal is to have minimal solar heat gain into your rooms, then you're going to want to paint these black so that they reflect as little light as possible into the house. And to get paint to stick, things need to be clean. So, since I'm really nice, I'm going to demonstrate to you the short-term results of not cleaning this stuff. Oscar Wilde says that looking good and dressing well is a necessity, but having a purpose in life is not. So you should wear your best clothes when you're painting. I am using an oil-based paint because it does tend to stick to metal better. And let me tell you, I'm about to do a real high-quality job here. Oh yeah. Woo, that smells good. It's all about looking good, folks. Looking real good. Hell, why am I even using a rag? I should use my face. Now I'm lining up. My line on the sheet metal brake. That's close enough. quite clearly I could not get, can't see the screen, couldn't get a true 90, but I started the bend, and that's the most important part. So I'm going to go along here for me to bring the angle a little past 90 degrees, so I can get my, once I let go of it, it'll be 90 degrees. Alright, once you get that, then you can pre-drill some holes in it at places that you'll be able to fit the drill. Now I'm going to have a beam running up here, so I'm going to want a hole that isn't going to be covered by the beam. And then this will be fine. Now that it's 1 in the morning, I can begin to do outdoor work, making noise, because it really doesn't give you that sort of thrill as does knowing that your neighbors were asleep before you woke them up. Additionally, it's Labor Day, so I should be doing labor now. I went to the hospital earlier and told them I was in labor, but that didn't really go over very well. So I'll just perform some manual labor. Okay, now I've placed screws and washers through the holes. This bottom board is straight along this direction. That's important because the sheet metal is going to bend along that board. And verify that your screws are going through the holes. And I'm going to secure one at either end. Okay. I'm going to secure the other side. This will make you go deaf quickly. All right. Not really sure what to bend here, or if this will even work. Okay. I guess that's it. Here's another ghetto fabulous method of bending. Got a sandwich. Sheet metal is the meat. And the edge of this is going to be the fold point, fairly certain. So, got to clamp down and we'll just give a little twist. Now, this line here is going to be perpendicular to the angle of the metal, so I'm just going to make it, whoops, looks like I didn't have enough pressure. Just going to make it like that. etc. Just gonna remove that. Okay, drilled my vent holes, pre-drilled my screw holes. Now I'm cutting those little thermal expansion slots. The third awning, type of awning I built, utilized the sheet metal brake, and it utilized a sandwich to get the long angle bends, including the top ribs. And I gotta say, so far of what I did, this is my favorite. I still utilized box beams. I painted the inside black to reduce light bouncing off of this and into the room and creating heat. Even though I've got this radiant barrier here, I'm not exactly sure how efficient it is and how much heat is generated behind the glass. And I just didn't want to have to worry about that. So I just painted it black. And of course that'll generate more heat, but the heat escapes through little holes in the top that I cut. And there's little slits in the flange for thermal expansion, so that the expansion and contraction forces are neutralized by allowing it to bend up and down. Now you'll see that there's a center support here, if you can see anything right now. And I didn't put that one very high up, because the higher up I put that center support, the more that expansion and contraction transfers forces to the fasteners. But the farther it is, the less energy is transferred to the fasteners. So I kept it a ways away for that purpose. Otherwise it would have been convenient to stick the flat bar up at the top, because that would keep the top really flat, which is what I wanted. It was really a cosmetic concern, and that's why I put the flat bar in there. It's especially true since I'm using coil stock that's not flattened, so it has a natural curve that I have to straighten out. However, with this method where you're making mock standing seam roofing, you won't have that issue. I really do recommend for most of you, I recommend buying a bunch of pre-cut sheets of aluminum and bending them into standing seam pieces yourself, and buying support members. Yeah, I hope it's been enough information for you. I wish I did it a more normal way, so that normal people could go out and have an example that works best for them. But I guess you're still out of luck. I don't think there's anything else on the net that is going to really help you very much, except your own imagination. The remainder of the video is for vampires, aka real white people, my brethren. I know how hard it is to try to sleep the day away with light pouring through your window. I understand what it's like not to be able to afford a coffin, or the increased air conditioning costs associated with sleeping in a coffin. So I've developed an insulated window awning that blocks out the light. That's better. These are the shoes I'm going to wear to my wedding, so I gotta keep them together. I put some paint on it in case somebody actually looks at the window. Removes my radiant barrier that I have covering the windows on the interior. So, put some paint on it to make it look rather uniform. I'm good with just one coat. And the paint hides a bunch of little brackets that are riveted to the edges that hold down these foam pads. Foam pads are glued on as well, but I didn't want to rely on the glue. I cinch this down, it squishes against the window. This bottom flange here actually latches on to the flange that I have installed on the window. This is so that I don't have to use any fasteners on the bottom. So the only fasteners, there's two fasteners. There's two fastener holes. Get your floor jack and an appropriately lengthed piece of crap. Jack it into place. That is a high-performance awning. And this is you looking at my window in the middle of the afternoon on a very sunny summer day.